so much easier. So that's the end of my foam roller. So, and there is two. So anytime that I would recognize and see there was a spot, I would add spots. Just because otherwise it ended up, and it would break it also up, so it doesn't quite look like there's, you know, I didn't want like a definitive pattern where people went, oh, and you moved it there, and then you moved it there. So, when I do this, whenever, like, say if it was this one, I would find this one, and so go lower, but anyway, and then I would match this up again with the next one. And so that thing's huge. It's big.
Okay, now for the circle, there aren't any foci, right? That's for an ellipse.
This, which is actually the top of it.
What's it
So,
called?
if you look up here, you start, see where I hit the ceilings, you guys aren't telling nothing. I would put this up on the very top, and then
So
like this one on the top of that. And I use just
this that you see right here is a general form, and you're right. The center, so you do know some stuff. The center is h comma k. So if I have a circle that's like,
okay, well, and you can try that, but I just use blue tape because then I would move it, and then I would do the next one, and then I would just move that down, tape it again, and do the next one, and then so I never stop.
let's make this.
So you line it up.
Let's just make this 16.
No. So what I do
Okay.
is
So
I line them up.
that center would be 4 comma negative 8, and then your radius would be at 4, and then your diameter would be equal to 8. So if I were going to plot this thing, I'm going to go to 4, negative 8, and I'm going to put a dot there, and then I'm going to go up 4, I'm going to go over 4, I'm going to go to the left 4, and then I'm going to go down 4, and then I draw the circle. And I could draw several tangent lines that are pretty easy. I could draw this line. I'll do it in another color.
Well, a lot of times they'll just give you like x equals 5, and that's like the tangent line.
Okay, because the tangent line for that would be y equals 4, right?
Okay.
Or you could do x is equal to 8, right? Because that would be another one of the tangent lines.
Yeah.
So the easiest way to find the tangent line is just to find the x or y line that you can draw that's on one of the points on the circle.
Okay. What if it's just given the tangent line?
You need the tangent line and the radius.
And the radius?
Right. Because you need to know how far away from that line to walk in order to put your circle, your center.
Okay.
Right.
So could you just walk through it if it was like the radius was 4 and the tangent line was any number? I just want to know like how you get from those numbers and how you plot them up.
Okay. Are you going through a point? Does it give you a point on the tangent line?
Usually it would just be like x equals 5 or y equals 5. So it's just a line.
Y equals 5. And it doesn't...
I thought it usually gave us a center or something.
Okay. And then it gives you h and k?
Yeah, maybe.
It's the center at... Okay, let's say 3 comma negative 2. Let's say the center is there, right? So let me erase some of this.
So I did this. I have the picture. I can show you someday on my phone. I had it where it was multicolored with all the colors in it. And everyone kept saying, no, I really like it. I'm like, yeah, I really like it.
I'm going to draw this for you first.
Okay.
It took me so long because I did it by hand with a paintbrush and each one of these, doing them in different colors and doing all this. So
Alright, so we have a center, 1, 2, 3, 1, 2. I put the dot there. Then I'm going to draw the line, 1, 2, 3, 4, 5.
Oh, yeah, that's gonna be wrong. I never noticed. Have you ever seen this?
So if I go directly up from this point, from this 3, right, and I go up to here to the tangent line, that's going to be the point where the line is tangent to the circle.
Okay. And would that also be the radius then?
That would also be the radius. So your circle is going to be something that looks like that. And now in order to find the radius, and I can make this more difficult, but you probably will too. In order to find the radius, all I got to do is just count how many spaces up that I went. So this radius is going to be equal to 7, right? So then I can say that my formula for my circle is x minus 3 squared plus y plus 2 squared equals 49.
Okay. And if you're given the general form, how do you put it into standard form? Or what
Okay.
is standard form?
Okay, so let's say I'm going to use this one, right? I'm going to erase this picture again. How you get the standard form is you just FOIL this out. You FOIL this out. So this would be x squared minus 6x plus 9 plus y squared plus 4y plus 4 is equal to 49. And then I'm going to bring the 49 over here and set it equal to 0. So I have to put this together and that together, and the negative 49. So that would be 36, right? Negative 36.
Oh yeah. Sorry. I wrote down as a positive 49.
And then if you're going to write it in general form, you write the square terms first. So it would be x squared plus y squared, and then minus 6x plus 4y equals 36. And then that would be the general form for it.
Okay.
Now, if you want to go back the other direction, then you have to learn how to complete the square. And we can practice that.
Okay.
Hold on 1 second. I'm going to grab from my software. It's probably in here. I don't want to update yet.
Like I like the paisley, so the whole point was once I got this, I just wanted to do something, so that's where I decided.
Conics
I
circles.
think I'm somewhat familiar with squaring, but it
We're
wouldn't
completing
hurt.
a square?
Yeah, it wouldn't hurt to go over it, because I'm not good somewhere.
Okay. So let's do that top one then. Oh. No, well, it's a different, slightly different. Right. So
So even on the side, you can build a fence, I put 3 more, because I agree with you, I put a nice bright one, and then variegated and a nice dark green one.
x squared plus y squared plus 6x plus, is it 4y? Plus 9 equals 0. Did I write that right?
Yeah.
Okay, so we have x squared plus 6x. I divide 6 by 2 and then square it, so that's plus 9.
Yeah.
And then I have y squared plus 4y divided by 2 and square it plus 4. And then this is minus 9 plus 9
If you
plus
wouldn't mind if
4.
I could do this by myself first, because I'm
Oh.
pretty sure I got a lot of it.
Okay,
I
I'm
just
sorry.
want to make sure my
Yeah.
final thing's right.
Mm-hmm.
So it should be x plus 3 squared plus y plus 2 squared equals 4.
Mm-hmm. That's right. Okay, now I'm going to give you one with some different information in it.
Okay.
Center and tangent line. So this is exactly what you were asking me about. Let's make sure you can do that.
Yeah, we were supposed to take this test last class, but we lucked out because so many people were taking the SOL. We canceled it and we learned some easy thing about matrices. So center. Are we doing 6?
Yep.
Alright.
And I'll just let you work through it.
Should be x. Equal to 16. That should be it.
That's it. Sorry.
Let's see. Let's go on to parabolas.
Okay.
Yeah, let's see. I know if it's x squared, then it goes up, and if it's y squared, then it goes side to side.
Mm-hmm.
And I just gotta remember the formula. Seems like it's like what we always learn. God. Let's see. Squared. Would that be it? X squared plus h equals y plus k.
X squared. Put the square on the
minus,
outside. Put the square on the outside.
Yeah. Y x minus k.
Mm-hmm.
Squared equals y
Minus
Is it k?
K. Yeah.
Okay.
It's h with the x and then k with the y. Right.
Okay.
That's the general.
Okay.
And what would it be for y?
Then it would be equals minus k squared.
Good. You didn't switch the two. Mm-hmm.
Okay.
There should be an A in there, right? Like in front of the parentheses in general,
Yeah,
because
I'm
that's
not
part of the
totally sure.
directrix.
Yeah, parabolas aren't. I'm not good with at all.
Okay.
Like the directrix and the focus. That's all strange to me.
Okay. I think if we go to, do I still have my book open? Yeah. Did they do quadratics first? Might have, no, they're doing parabolas last, which normally they do parabolas first. I thought P was like 1 over 4A. I'm just trying to remember the equation for it. Yeah. So
4p.
4P. So if you want to know what P is, you divide it by 4. So
Divide what by 4?
I'll show you. Let's say that in general we have y minus 4 squared, and then let's put, I don't know, 12 there, is equal to x minus 6. And I want to identify my directrix, my axis of symmetry, my focus, all that other good stuff. So the first thing that I'm going to do is I'm going to identify my vertex, right? The vertex is at HK. So that means that it would be where?
It would be 6 out of 4.
Okay. How does my parabola open?
That would be opening to the right.
Okay, that's important because it's going to tell us where to put our focus. So I'm going to plot this to begin with. So this is 1, 2, 3, 4, 5, 6. And then this is 1, 2, 3, 4. So I'm going to put that point there. I know that it's going to open up this way, right?
Mm-hmm. Because A is positive.
Because
right?
A is positive. So now I'm going to take this number and figure out what P is.
Okay.
This thing is equal to 4P.
Okay. So P is equal to 3.
So if I count 3 inside this parabola, that gives me the focus. Also, I need to say this. Because it's a y term, I have an axis of symmetry that goes here. That axis of symmetry is y is equal to 4. Okay?
Okay.
Now I'm going to use this p-value. So I got to count 3 inside.
And then you'd go 3 outside for the directrix.
And then you go 3 outside for the directrix. It's that easy. This is 6, so this is 3. And then this is 6, so this is 9, so it should be like right there. And so I'm going to draw my directrix there, and then that points my focus. What is the line for my directrix?
It would be x4, right?
X equals 3, right?
X equals 3, yeah, sorry. I just didn't plot it right.
And so my directrix is x is equal to 3, and then my focus is at what point?
Let's see. If that would be 9.
9 comma
Same thing, 4.
4.
And then can we just go through it if it's your if you're given the directrix?
Directrix and the focus?
Yeah.
Okay, let me pull up a question here. So parabolas. And you're given the directrix and the focus. Directrix and the focus.
What?
Uh,
I'm sorry, can you say
do I really want them to be that nasty? I guess it doesn't matter.
Yeah.
It doesn't matter.
That's fine.
All right, might as well just do 10, right?
Mm-hmm.
Okay. So in order to find the vertex, how are we going to find the vertex? There's only 2 things that you need to find. You need to find the vertex and the P.
Okay.
So how do you find the vertex?
I thought if you I don't want if you found the P.
Huh?
It doesn't. If you find the P, then the P is the distance from that to the vertex.
What I would do is find the midpoint between the focus and the directrix, because that's going to give you the other point for the vertex. That's what I would do. Because if I'm drawing this thing, sorry. If we look at this picture, right? If you give me this line, which is my directrix, and then you give me that point, which is my focus, where does the vertex lie between those two?
In between.
In between. So that's what I would use to do that. Now, this one is slightly different because my directrix is now y is equal to something, right?
Mm-hmm.
So what kind of parabola am I expecting out of this?
It would be.
Is it going to be an x squared parabola or a y squared parabola?
X squared.
It's going to be an x squared.
73 divided by 8. That's not much. Okay.
It's like.
So, well, 71 over 8 is equal to 8.876, and 73 divided by 8 is 9.125. So in total, the vertex should be at 9.
It'd be at 9 because that's a halfway point, right? It's 72 over 8, which is 9.
Yeah.
Okay. So what are the points for your vertex then?
So then for the point of the vertex, y is equal. No, not equal to. It should be y minus 9. Before that, it should be x is x plus 7 squared. And then we need to find
The P.
this. Would the P always be in front of the parenthesis?
Mm-hmm.
Okay. And
It's
so,
4, and it's always 4p in front of the parentheses,
okay,
right?
so it's 4p and 4. So, would it be the 0.125 that I got? Because that would be the center to there.
Point to get us 1/8. Mm-hmm.
So,
So multiply 1/8 times 4.
alright. Be 0.5.
And then take the reciprocal of it.
1 over 0.5? I don't understand.
Well, what is another way of writing 0.5? How do you write that as a fraction? That's why decimals are hard to use when you're doing this
1
stuff.
over 2.
So it'll be 1 over 2. Now, my question to you is that parabola opening up or down? Look at where the focus
It
is
would
and
be
look.
down. So
So
it would be negative 1.2.
So it would be negative 2, because we got to take the reciprocal of that.
Alright, I don't follow.
You're going the other direction, right?
Yeah,
You see how p is equal to 0.5 there?
mm-hmm.
Do you see how when you're actually writing this equation, you have to take the reciprocal of it? Does that make sense to you now, since we worked it the other way?
Okay.
Right? Because that's the value that you got for p, right?
Yeah.
So the number that goes here is 1 over 4p.
I just don't think I got 0.5. I don't think I wrote 0.5.
You got 0.5 when we did this, okay? The original thing was, right?
I got 0.5 when I multiplied it by 4. The original thing I got was 0.125. I mean, how I got it, I could have been wrong, but only thing I did was I just went. What was it? 9.125 minus 8.875.
So where's the vertex? The vertex was where? Tell me again. Negative 7 comma 9, right?
Yeah.
And the directrix was
73 over 8.
y equals 73 over 8.
Mm-hmm.
So I'm going to, in order to find my p, I'm going to subtract those two numbers from one another. So 9 or 73 over 8 minus 9. So that's 1/8. And
Why are there 2 9s?
sorry. I was going to do 72 over 8, but I just subtracted it.
Okay.
And that's equal to p.
Mm-hmm.
Or is that equal to 1 over 4p? I think that's equal to 1 over 4p.
We could always just see the answer and see what they got as p.
I think that's equal to 1 over 4p.
Okay.
That distance between the two is equal to 1 over 4p, because if I do that, then P is going to be equal to 2.
Okay.
And that's the way that I've normally used it. I think that this equation that they have written in this book, you see how that's with the square term? And they have everything written over on this side and it's all solved for y.
Mm-hmm.
When it's written in vertex form that way, then the P is over on this side. Now let's look in this textbook, and I bet you that P is going to be over with the y squared term, with the non-squared term. So you see how that's with the non-squared term?
Mm-hmm.
So if I were to move that over to here, what would you get? How would you move that 4P? Huh?
1/4. You'd have to divide it.
Yeah, you would have to divide it. Do you see how that works? So if you're going to write the P with the square term over here, then it's 1/4P, and that's why it's 2. And that's the way that I learned it.
Okay, so it's always with the x though. So if I don't have to do that, P's always with the x usually. Unless if it's like y squared or x squared.
I have a tendency to always put it over with the squared term. So I'm always doing 1/P. Because when you're writing stuff in vertex form, that number is normally in front of this parentheses. It's not in front of that one.
Okay.
Or if you're going to write it in general form, it's normally either solved for the non-squared term.
Okay.
Right? The reason that I'll tell you the reason why I would do that. They give me one that has an x squared with it now. But let's look at our equation. So our equation was -2 x minus or plus 7 squared is equal to y minus 9. Normally when you actually see this equation, it's solved for y because that's a function. And so if I put that multiple with this squared term, then I can easily solve for y. Which is the equation that you get.
Okay.
So the number in front of the square term is always going to be 1/4P. So the distance that you find between the directrix, and it doesn't matter whether it's opening up or down, the distance that you find between the directrix and the vertex is equal to 1/4P. So that kind of just stays consistent, so you can always do the same thing over and over and over again. Because that's closely related to actually how you actually do the math from the graph, right? Because we were able to find this number by just subtracting the two numbers.
Mm-hmm.
Because our directrix was over on this side, and then our vertex was here. Sorry. We didn't do that. Our directrix was on this side, and our vertex was here. So we knew that it opened down.
Yeah. I'm sorry. I just did not see how that equals. Alright. I don't know if it's probably just me, but.
Take the reciprocal of both sides. Because the P is on the bottom, right?
Yeah, so. Let's just say times by 4.
No, don't do the math that way. They're
Okay.
both fractions, right?
Mm-hmm.
So just take the reciprocal of both sides. Flip over the fraction on both sides. So what's P equal to?
Okay.
Okay? That's the easiest way to do that math.
Alright. What's wrong if I do it this other way?
You're saying that 1/8 is equal to 4p, which it's not. The 1/8 is equal to 1 over 4p. The way that you did it before, you said that 1/8 was equal to 4p.
Okay.
Or what did you do? How did you get 1/2 before? How did you get 1/2 before?
Let's see. I did 1/8 times 4.
So you said that the 1/8 was actually p? Is that what you did?
Yeah, I put well, what I was gonna do is 1 over 8 equals 1 for p times 4, so it'd be 4 over 8.
Is equal to 1 over p.
Yeah.
So you still have to take the reciprocal of it.
Yeah. So then it would be 2 equals 1 over p, then 2 equals p.
P.
Okay. That makes more sense.
Let me give you another one to do. See if you can get that equation.
Let's see.
Did you get it the wrong way?
I got 3 over 2.
For the... How far away is the focus from the vertex?
I thought it was 1/6.
It's 1/12, right? Because the difference between the two of them is, that would be like 72 over 12.
I think instead of the vertex, I put it the difference between the foci and the diacritics.
That's twice, right?
Yeah.
Because the vertex is a midpoint between those two.
I think I did that twice, actually. Alright, so That's one thing I got wrong. So.
You get that though now?
Yeah. Minus. So when they're asking me to put this back into like a parabola, do I have to make it y equals or?
Well, where are the directrix and where are the? You see the directrix? You can write it any way you want. You can write it that way if you want.
Okay. I just don't know
If that's the way that your
off.
teacher wants it in standard form, then that's the way you write it.
Okay.
I'm used to writing it that way.
Okay.
Either y is equal to something or x is equal to something.
Okay.
So the non-squared term is the one I'm solving for. That's normally the way that I write it.
Okay. Non-control
I mean, the only thing that I don't remember about ellipses is the eccentricity. Because I normally just find the vertices and the foci. So let me go to ellipses and see what the equation for that is.
It's x minus a squared minus.
Oh,
y
no.
minus k.
I'm talking about the thing that they're actually looking for. This. It's a hyperbola. Difference between the circle and the ellipse is that your x squared terms are not going to be the same. But let's go to their chart. Okay, so E is equal to C over A. Do you know what C is? C is the distance from the center to the foci.
Okay, so C is like the new like P, right?
Sort of, kind of. You find it differently though.
Okay.
Okay, so I think I should probably just use my software to give us an ellipse equation. And I'll get one in standard form, and then we'll go through how we find all the different pieces. It's probably the easiest thing to do. We'll start there. Okay, so that number right there represents your a squared. That number right there represents your b squared.
Okay, so this is.
Now, the major axis is defined as the bigger radius. That's all it is. So if I'm drawing this picture, the center would be at -7, -7. So -10, 9, 8, 7, -7, 4, 5, 6, 7. That would be there. I'll write the equation up here. This one was 64, and that one was 144. That's 1. So this is my a squared. This is my b squared. So my major radius is 7. Sorry, 12. Yeah, I don't know what I was thinking. 12.
And mine was 8.
And the minor is 8. So I'm going to count up 12 from here. So that's 7 and 5 more. It's going to be huge. So I put one of them there. And then I'm going to count 12 down from there. And then I'm going to count over 8. And then I'm going to count this way 8. Okay. So this is what my ellipse actually looks like. Since this is my major axis, my foci lie on that axis, right? So I do b squared minus a squared is equal to c squared.
Mm-hmm.
So 144 minus 64 is 80. Did I do my math right?
Yeah.
So I take the square root of 80. The square root of 80 is the 16 going to 85? Yeah, right? It goes in there 5 times.
Yeah.
So it's 4 square roots of 5. And so I'm going to count up 4 square roots of 5 up, which is somewhere around 9. I'm going to put one foci there, and I'm going to count down 9. I'm going to put one foci there. And then, was it C over A is equal to E?
Mm-hmm.
And so
is it always A though?
It's always A.
Okay.
Let me double check that, because it might be the major, it might be the minor axis. So let me see what they say here. I just want to make sure they don't flip flop. They just keep A as A and B as B. So in that equation, they say that A is 25, and when they switch the two, no, that's still major. They're saying that A is the major axis. So the way that I'm doing it, you're going to have to switch the two, because it might be B.
Okay.
But it's always the major axis that you're going to divide by.
Okay.
So in our case here,
it would be B.
It would be B. It's always the major axis. So it's C divided by B is equal to E. So just remember that it's always the major one.
It would be
4 square roots of 5 over
12. Square root of 5 over 3. And what does this give you?
It gives you the shape of it.
So,
like how oblong or how circular it is. If it's closer to 1, then it's circular. It's more circular.
okay. So given that, will you be able to have different points at a specific spot?
I think you can find the different points from a specific spot just by knowing the formula of the ellipse, because if you have a point that's on the ellipse, you plug X and Y in there to figure out where it's supposed to go. Sorry, burping.
And
Okay, so it says that If E is a fraction, what does that actually mean? If E is close to 0, then it's near the center of the ellipse. And if E is close to 1, then it's closer to the edges. That's all the E means.
Okay.
But we can already find the location of the foci, so I don't even know why you're doing that. Right? Because we know the location of the foci by just doing plus or minus C from the vertex along the major axis.
So E is just kind of pointless.
E is kind of pointless. That's why I never used it. Because we already know what C is. I already know what the major axis is, and I already know my focuses are on the major axis. Sometimes textbooks make things way more complicated than it has to be.
Okay.
But at least you know how to calculate it, right?
Mm-hmm. And so what are the major vertices and the minor vertices? Are they just the point?
Though the points that I you remember those points that I plotted? Right.
Yes.
So the major vertices are the ones on the major axis,
Okay.
and the minor vertices are the one on the minor axis.
Okay.
Because you have two different radii. That's the way I look at it. Because I don't want to make it more complicated, and you'll get the right answer by doing it that way.
Okay. And what was the foci again? Wasn't that?
It was b squared minus a squared. So it's the major axis minus the minor axis.
So so c squared is the foci.
C squared is the foci, and you go plus or minus from the center.
Okay.
So you got your center points there, right?
Mm-hmm.
And so you go plus or minus your center along the major axis. So whichever number is bigger tells you your major axis.
Okay.
So like in our question, that one's my major axis, right? So I'm going to put my foci along that number. So I'm going to go plus or minus 7 from C, right? I'm going to go from that up or down. That's what I did in this picture. You see how that was 7 right there? Or negative 7?
Mm-hmm.
And I went up from there that much, and I went down from there that much, and I went along that axis. And I know they give you an equation for it, but if you can visualize it, you can just count it. You know what I mean?
So you just went up 7 and went down 7?
I went up 4 roots of 5.
Okay. Oh, okay.
Right?
Okay. Yeah.
And remember, because I'm switching, I'm always keeping my B there and my A there. I'm always going to take the big one minus the little one. So if the 144 was there, and the 64 was there, then that would be my major axis. And then I would have gone this way with my C. So it would have been A minus B equals C.
Okay.
So always take your major from your minor.
All right.
And then take the square root to find C.
And so the foci would be 4 square roots of 5. What is it?
Plus or minus that number, minus 7.
Okay. And you just have the x value in front of it, right?
Mm-hmm.
Okay. And that would change whether or not it's the major or the
minor. If these two had switched, then I would be doing it to that one, right? And then I would just leave that one alone.
Okay. And then
I actually have to go to another appointment.
Okay. Well, thank you. That was a lot of fun.
Hyperbolas do exactly the same thing.
Are there just a minus in the middle?
There's just a minus in the middle.
Okay.
And so you're going to have a major and minor axis. You draw the box, and then you put your vertices along the box.
Okay. And then you just know that you can't make like a circle. You just make it like all on the outside.
Yeah, because when you draw your box, you put the diagonals in. So you'll have your center. Let's say your center is. Let me just draw it really quickly. Okay, and I'm going to do it in different colors. So let's say that that's my center, right? And I have a major axis, right? And it's this way. So let me put those numbers in. So I'm going to do that and that. And then I have a minor axis. And from that, I build a box. And those are what your A's and your B's are. Okay? And then you draw in the diagonal. Okay? And then your hyperbolas are going to come off like that,
Okay.
where they don't cross those isotopes.
And they're only on the major axis? Right?
And they're only on the that's the way they open. They can either open up or down, depending on
If it's the major.
if it's the major or not. But it's always going to open along the major axis.
Okay. All right.
So it's the exact same thing that we just did with ellipses, except for instead of drawing a circle, I build a box and then draw the things in.
Okay. Thank you.
Mm-hmm.